Here's a system of two equations. In a preceding earlier video, we graphed that system, and the graph looks something like this. Here's the graph of negative 2x plus y equals 1. Here's the graph of x plus y equals 2. And they have a point of intersection, which we determined to be 2/3, 5/3, but that's not particularly important. So, I mean, it will be right now. Right there's our point of intersection. Now, what we've done here, algebraically, we've determined an equivalent system here. That is, a system whose solutions are identical to those of the original. Now, this equivalent solution that we arrive at down here simply says x equals 1/3, y equals 5/3. So this system would have a graph that looks like this. The line x equals 1/3 is right here. And the graph of y equals 5/3 would be right here, assuming that 1 is up about here, so this is 1/3, and 1 is up here, so this is about 5/3. Okay, so the intersection here, if the algebra between here and here, which we're going to explain is correct, has to be the point where these two cross, which is a point where x is 1/3 and y is 5/3, so that would be 1/3, 5/3. So x equals 1/3, y equals 5/3 is a solution to the system. The equations that we have here give us this graph. Now, every step we take from here down to here gives us an equivalent set of equations. By equivalent, that means that the solutions to this system are the same as the solutions to this system, are the same as the solutions to this system, are the same as the solutions to this system. I know this is getting monotonous, but are then the same solutions as the solutions to this system. And for this system, the solutions clear. Okay? So, we're not all that interested in how these lines change with every step, although we could model that, and at a certain level that would be pretty interesting, but we're going to not deal with that right now. That's something you don't want to think about right now. What we want to think about is why each of these systems is equivalent to the one before it. Well, I'm going to move backwards, and then we'll see how we move forwards through one of these systems. X equals y and y equals 5/3 are equivalent to this. Because y is 5/3, if we subtract 1/2 y from x, what are we going to have? We're going to be subtracting 1/2 of 5/3, right? And if we subtract 1/2 of 5/3, which is 5/6 from 1/2, I'm going to say we're going to get 1/3 and we don't. Well, maybe I better work through this in the opposite direction. Why should that not work? Yeah, going to work through it forwards. I know this is the right solution. I'm not practically sure of it. But what I just said should have been true, but wasn't. We'll see what I'd said wrong. Okay, so forget what I said. Let's start up here. Okay, now, here's the system. Now, if we see down here, I haven't touched this second line, have I? Okay, the second equation is the same as the first, but this one has changed. So we've replaced this equation with this equation. Well, why should that not change the solution? Well, it goes back, and you aren't going to necessarily discover what I did. I'm going to explain in a minute. What I did here was I just replaced this equation with 1/2 of itself. Okay, what's 1/2 of this equation? Well, we multiply 1/2 by everything in the equation. 1/2, actually negative 1/2, and there is my kicker. Yeah, Okay, this should have been negative 1/2, so what I was starting to say a minute ago was true. I got careless writing that down. Anyhow, don't let that distract you. Okay, so what I'm saying is that this is negative 1/2 of this equation, okay? So we replace equation 1. Now by equation 1 at any step, I have equation 1 and equation 2. And then I have equation 1, equation 2, equation 1, equation 2, and so forth all the way down the line. So when I'm at this step, equation 1 is this, equation 2 is this. But the new equation 1, of course, is this. So we're replacing equation 1 here with negative 1/2 times equation 1. And you should verify if I multiply everything in here by 1/2, this is what I get. Okay, now, from this step to this step, I don't do anything to this one, but I'm replacing equation 2, obviously, because it's different. So I replaced equation 2 with what? Well, again, you're not going to discover what I replaced it with, but I'm going to tell you what I replaced it with and ask you to verify that. What I've replaced equation 2 by is the former equation 2 minus equation 1. In other words, here's equation 2, here's equation 1. I do this equation minus this equation. Now, among other things, that's going to give me x minus x, isn't it? So you notice I don't have an x down here. It's gone. Now, I could write that as 0x, and I will, just to keep numbers in all the places, and you'll understand there's a reason I did that. So I'm going to write a 0x here as well. Okay? But now I did equation 2 minus equation 1. So I'm going to point to it, and then I'm going to write it out. Because naturally you're going to want to write these things out to make sure you're doing them right. But x minus x gives us 0x. Y minus 1/2 y is the same as y plus 1/2 y. And y plus 1/2 y is 3/2 y. And then 2 minus 1/2 is this should have been minus here, it should have been minus here, sorry. 2 minus negative 1/2 is 2 plus 1/2, which is 5/2. Okay. In the very first step, when I multiplied by negative 1/2, I would have multiplied 1 by negative 1/2, and I would have gotten negative 1/2. So that's what I would have had here and here and here. And then what I get down here depends on a couple of things. Okay, well, we'll get to that in a minute. Okay, so I've replaced equation 2 by equation 2 minus equation 1. And now what have I done? Okay, what's the difference between, well, the first equation hasn't changed, has it? That's why my negative 1/2s work all the way down from here. Okay. What have I done to the second equation here to get this? I've replaced equation 2. Well, the difference is I have 3/2 y here, and I just have y here. Now here's where I tend to lose people, because people haven't done fractions. Our educational system does a terrible job with fractions. Put a calculator in your hand and think you know fractions. You know, they think you know fractions, you know better. But, you know, you never learn it that way. Okay, anyhow, if I multiply 3/2 by 2/3, I get 1. And I'm not going to belabor that. When I write it out, I'll say why. But if I multiply everything in this equation by 2/3, well, 0x times 2/3 is still 0, or 0x, okay? 2/3 of 3/2 is 1, so I get y. 2/3 of 5/2 is 5/3. Okay, now that's a simple fractional calculation that, you know, you should understand as soon as you write it out. And if you don't, you need to review it. Anyhow, so multiplying everything in equation 2 by 2/3, I get this equation. So I replace this by 2/3 multiplied by equation 2. And now what do I do? Well, the second equation here is the same as it was here. So I haven't done anything to it. What have I replaced? Well, the first equation is different, so I replaced equation 1 by something. What have I replaced it by? Well, what I've done, I don't want anything there. I want a 0 here, okay? So I don't want a y. So what do I multiply y by so I can add it to -1/2 y and get 0? Well, I take equation 1, this one, and add it to 1/2 of equation 2. Half of y is 1/2 y, and add that to -1/2 y, I get 0. Now I could write that 0y. 1/2 of 5/3, as I said before, is 5/6. And 5/6 added to -1/2, well, that's 5/6 added to -3/6. 5 minus 3 is 2, 2/6 is 1/3. Now again, I'm going to write that out. So if you didn't understand that fractional calculation when I said it, I'm going to come through here and do the side calculations. What you need to see here is that I've taken this, and the first thing I did was I put a 1 in front of x here, because that makes it easy to figure out what multiple of this to add to this to get a 0 here. That was my goal here. And then down here, I had a 0 here, but I want to get a 1 here. So I concentrate on getting a 1y here. And then I concentrate on getting a 0y here. So my goal was to get a 1 in front of x, then get a 0 in front of x in the second equation, then get a 1 in front of y in the third equation, and then just a 0 in front of y in the first equation. So that's kind of the order. It's kind of like I go counterclockwise around the equation. Change that to a 1, change that to a 0, get that, change that so I have a 1, and then change this equation so I have a 0 there. Okay, and you understand that if I can do that, then this equation is just the way I wrote it originally. This just says x equals 1/3, y equals 5/3. And you recall that when we solved these equations originally, or when we graphed these equations originally, and then we solved them, we verified that the intersection point was 1/3, 5/3. Remember, we estimated this was 1/2, 5/2, 1/2, 3/2. That was the estimate, that's a couple of people got, and that's the one we used. And we compared that with this and saw that our estimate was pretty good. But when we did the algebra, we got this. Now, you probably ask, why in the world am I complicating the algebra by doing all this? Well, because ultimately this really simplifies the algebra in a way that you're going to see fairly soon.